Hi, Cara. Right, so looking at asymptotes for question 1 of the analysis calculator paper. Yeah, asymptotes are a bit of a weird one because there's no sort of hard and fast rules really. It just depends on the function you're dealing with. So the first thing I do is draw the graph, have a look at what it looks like. So here I've stuck the graph up on the calculator screen, and I can't remember how to do this now. No, was it that one? No. Okay, now here, because we're only, if you read the question, it says it's only when f for values of x greater or equal to 0, which makes sense because x is the number of years that you've had. So so it can't really be minus 0 years. So so starting at 0, you can see that there's going to be no vertical asymptotes for this one, but it looks like there could be over here a horizontal asymptote. It looks like it might be trending off towards horizontal asymptote. So that's only going to start happening though when x gets really big. Like the bigger x gets, if it's going towards a limit, then as x tends towards infinity, positive infinity in this case, then it should be getting closer and closer to its asymptote. On the other hand, if there is no asymptote, as x gets bigger, then this will just continue to very slowly creep up, and eventually it will reach infinity. You can test that to see, and I suppose so. This is a sort of a general way of looking for horizontal asymptotes. Is to let's get a new page up. Right, bring that, add calculator. Okay, so we're going to go and have a look what happens to this function as x gets very big. So I want f1, which I've already defined, and I want to see what happens when it gets very big, when it goes towards infinity. Down here on the calculator there's this pi button, but also there's a handy infinity button. So I'm going to say, right, what happens to f1 as x goes towards infinity? Now I'm going to hit enter in a second. It's either going to give me undefined or infinite, or it's going to tend to a limit. Okay, so here it tends to a limit. It tends to a limit of 3. So that means that it's going to be a horizontal asymptote y equals 3. Okay, it's going to go towards 3 but never go above it, which in the context of this question means that the sales will never exceed 3,000 in any year. Doesn't matter how long it's on the market for, if the model is correct. So that's for this particular question. So and there's a couple of tips. Have a look at the graph, see what it looks like, and then you're looking for stuff like let's have a look. Rubbish graph. Right. No. Okay. So you get graphs where it's fairly obvious. Then you can have a look and get an idea of whether it has got a vertical asymptote or not. Now, vertical asymptotes happen when you've got functions like I should have done this before because it's rubbish to do while it's recording. Like that, stuff like this, where you've got a function over underneath something else. You've got a function of x underneath as a denominator somewhere. So I mean, you could have like 3 plus this, for example. But it's the reason you get an asymptote is if this becomes 0, anything divided by 0 becomes infinite, and therefore the y value becomes infinite, and therefore you get the break, you get the asymptote, the vertical asymptote. So if you're looking for vertical asymptotes, then it tends to be with a function that's got some function of x as a denominator, and it'll be the value of x that makes this 0. So you can, because it's calculator paper normally, you can do solve. It's on the calculator, obviously, rather than just scrolling it across your page. Solve, and here would do, in this particular case, would do 2x plus 1 equals 0 in terms of x. So you stick that in the calculator, find the value of x that makes it true. And it could be a combination of functions. So you could have stuff like 3x plus 1 all over, I don't know, x squared. I don't actually know if this is one that would work, but 2x plus 1, say. So again, if here we've got a function of x as a denominator. There's other stuff here. There might even be stuff over here as well. 4 plus, it might look like a complex thing like this. But it's the fact that if this denominator here goes to 0, the whole thing will be infinite. So so you just try and find the denominator, and you find out the value of x that makes the denominator 0, and that's where the vertical asymptote would be. Okay, so so a quick recap. You've got to start with these. You've either got have a look at the graph, see whether there's likely to be vertical or horizontal asymptotes. In this case, it looks like it's going to be a horizontal asymptote. To check for horizontal asymptotes, you take the function, you put infinity into it or minus infinity into it, and see what happens, and see if it does tend to a limit or not. For vertical asymptotes, then you have to put the denominator that contains x, the function of that contains x for a denominator, and find out what value of x will make that naught. And that should give you the value of x. It's then worth getting back to the graph and just making sure that makes sense in the context of your graph. So, like in this case, where are we here? If if this looks like it's about -3 on the graph, then you've got an idea at least of what it should be, and then you can check it against the answer you get to this. Okay, marvelous. Hope so.